The last objective of section 2.1 on functions is that of solving applications. The student will be able to solve applications. Mathematical modeling. The price demand function for a company is given by P of x, that's the price P of x, price is a function of x, equals 1000 minus 5x for x between 0 and 100 inclusive, where x represents the number of items, okay, the number of units produced and sold, which is what x always is, and P of x represents the price of the item. A, determine the revenue function. Okay, so we're going to create a revenue function. And B, find the revenue generated for 50 items being sold. So to produce a revenue function, we have to keep in mind the big formula that R equals, we usually say R equals XP. R equals number of units times the price per unit, a unit price. But this time we're going to write it as price times X, number of units. So R equals PX. R equals PX, price times quantity. And so here's the P, and then you've got X. So price, as was given in the problem, was 1000 minus 5x. There's price times X. So that's a revenue function. It will return, the revenue function R will return the revenue for a certain number of items produced and sold, a quantity. Revenue, of course, is the amount of money that comes in sales. So it makes sense that it is the number of units times the price per unit. Then B, what about R of 50? When 50 items are sold, what's the revenue? So we just substitute 50 in for X in our revenue function. And so we have 1000 minus 5 times 50 multiplied by X again, which is 50, and that's 1000 minus 250 times 50. 1000 minus 250 times 50, which is 750 times 50, or 37,500. Right? 750 times 50 is like 275 times 100. So yeah, 37,500 will be the revenue when 50 units are produced and sold. What is the domain? Well, the domain of the function has already been specified. Okay, so that might have been part C. What is the domain of this function? Well, they gave it to us in the problem. There it is. There's D right there, set of x values. Break-even analysis and profit-loss analysis. We are told that any manufacturing company between 0 and 100 C inclusive, and revenues including the 0 revenue is, and including the 100. And there are costs, of course. And the company will have a loss if R is less than C. If your revenues aren't as much as your costs, they will break even. The company will break even if R equals C, and the company will have a profit if R is greater than C. Costs, there are two kinds, fixed and variable. Fixed costs don't depend on how many units you produce and sell. So plant overhead, the warehouse that you have to maintain. But then there are variable costs. They depend on the number of items produced. So your machinery, you're going to have to spend more on machinery if you're going to produce more, and labor as well. So here's a general equation for cost. Fixed cost plus variable cost rate, X. Of course, this is really just Y equals mx plus b, where the mx and the b have been switched. Price demand functions, usually determined by financial departments, right? They take statistics and then they produce this model, a linear model in this case. Price demand functions play an important role in profit loss analysis. And price equals m minus nx. X is the number of items that can be sold at P dollars per item. And so with that negative coefficient of X, in general, you have a decreasing function. Price is a decreasing function of number of units. So as the number of units produced increases, then you have all of these units available for the public or whomever. Then all those units are just out there. Demand decreases and price decreases. So it's a linear function with a negative slope. Revenue function is R equals XP, right? We talked about that important formula. R equals XP. And we can substitute m minus nx for the p in that formula to make a new formula. Well, profit is revenue minus cost. So that's, the other big formula that we have to remember. Profit is revenue minus cost. Well, we made a new expression for revenue. We could substitute that in, put the m minus nx into the revenue function, giving us x m minus nx. Subtract from that cost a plus bx, because of course if you're going to graph cost c of x on number of items x, of course that's going to be an increasing function, and because costs increase as production increases, well, for some number of units in here there's going to be an equilibrium. You can see that coming, but you get an expanded expression for a profit function. I don't suggest you try to memorize that. Just memorize what is circled here, that revenue is XP, profit is revenue minus cost, and since R is part of that, you can create more complicated formulas, but just remember those two things and you're good. Just remember P equals R minus C, and you have to remember R equals XP. Example: company manufactures notebook computers. Its marketing research department has determined that the data modeled by the price demand function, okay, there's a price demand function, a decreasing function, decreasing as we read from left to right, right? So this function has a domain 1 to 25, and it's a decreasing function as price functions are, price demand functions. X is in thousands here, so we're talking about thousands of units produced and sold, and that formula, that function returns a price. Here price is seen to be dependent on the number of units produced and sold, although in business we tend to think of it the other way. The number of units produced and sold determines the price. Actually, price determines the number of units produced and sold. We're going to set a price, and then there's going to be a result of that in terms of sales, in terms of units sold. What is the company's revenue function, and what is its domain? Well, we know all about revenue now, don't we? R equals XP. And then domain. Well, they just told us that, didn't they? So R equals XP, they gave us the P in the original problem. Substitute that 4P in the formula, R equals XP. And we can distribute the X if we want to. We don't have to. Last time we didn't do that. Usually we do it though. 2000x minus 60x squared. The price of this function is the same as the domain. The domain of this function is the same as the domain of the price demand function, which is x between 1 and 25 in thousands. That was given in the problem. There is your domain right there. Because that's a set of x values that are allowed. Here's a profit problem. Financial department for the company in the preceding problem has established the following cost function for producing and selling X thousand notebook computers. Okay, so here's a cost function. Cost function, and then of course we're going to turn around, since this has been called a profit problem, we're going to turn around and write a profit function for producing and selling X thousand notebook computers and indicate the domain of this function. The set of X values that are allowed. Of course, if we're going to make a profit function, well, what is the formula which we said was so important? Formula is that profit equals revenue minus cost. Since profit equals revenue minus cost, and our revenue function from the preceding problem was, that's the revenue function. Now they told us that, and that was the previous problem, but you've seen that 2000x minus 60x squared is the revenue. Well, profit is revenue minus cost. Of course, all of those things are a function of x. So when we say P equals R minus C, well, P of x equals R of x minus C of x. The R of x from the previous problem, the 2000x minus 60x squared, we're going to subtract from that with the cost function that we were given in this cost problem. Well, it's now a profit problem. We're going to subtract that, and we're going to simplify. So we can see that the coefficient of x squared is going to be negative 60. The coefficient of x, well, let's see. As we distribute negative 1, we're going to have negative 4,000 in there, which appears here. Negative 4,000. And there's also going to be a negative 500x. Negative 500x combined with the 2000x is 1500x. And that's that is the profit function right there. Domain, set of x values that are allowed. Well, it's the same thing as in the price demand function. No more x values became allowed, you know, just because we started talking about revenue, cost, and profit. So it's still x between 1 and 25 in thousands. And now for the filling in of the blank space that we've been waiting so long for. There it is, a graph of the profit function. Okay, so that's P of x, and you can see that it's a downward opening parabola, which is what we're supposed to have when we have a quadratic or second degree function with a negative lead coefficient. And so what this shows is that there's an optimal number of, they say cameras here, but wasn't it notebook computers? Yeah, so not cameras, notebook computers. There's an optimal number of them. That's going to be another problem. But if you produce and sell too many, your profit will be affected. Not only are there economies of scale, but diseconomies of scale in business. And I guess this is where all of the long-term costs of calibrating your business come in. New machines, new everything. Of course, on the low end, there are numbers of units produced and sold which do not maximize profit. You're not selling anything, you're not going to make the best profit that you can make. Now, yes. Okay, so there are some applications of functions. We had the price demand function. We talked about revenue, we talked about cost, and then we talked about profit. And remember the two big formulas, R equals XP and P equals R minus C.